takes a lot to put one of these things on. Anyhow, I'm David Hartley, K5Oz, and I'll tell you a little bit of a story. This is a picture of a lightning rig saver. Let me see if I can. Is that the laser? Which one's the laser here? Uh-oh.
Well, I don't know.
What?
Forward.
The forward's the laser? Which one's the laser?
The button on the front.
I'm pushing it, nothing's happening. Come show me. But anyhow.
Right here, the red.
Let me see.
The thing is, you pointed at the TV.
Oh, you get that. So, okay. That's. I'll get it back. Okay. My apologies there. So I was trying to point it at the TV, and it's fine. And that's why I didn't see the laser. It won't work on the TV. So anyhow, let me go forward to the next thing. That was the picture of the lightning rig saver. I am selling them out there. You could probably pass by the table. Nobody was there because I was prepping for everything else. But anyhow, the Ozone Club decided to, well, let me back up a little bit. What really drove this is about 10 years ago, I had lightning hit my antenna. The antenna was disconnected from the rigs, but it came into the house, got into the air conditioner upstairs, and started a fire. Okay, I was at work, and boy, I got it from my wife. So she said, "You need to make sure you disconnect." I was disconnected. Well, you need to make sure there's no lightning get into the house. I said, "Okay." So for several years, I went every day. So I said, "There's got to be a way of doing it." And of course, we live in the ozone belt, as you can see by this presentation. I won't follow this exactly, but we have a lot of lightning in the area. And boy, it gets into your rig, you're in trouble. But the point I want to make is, so I made a prototype. I actually got hit with this thing. It hit the tree that my dipole apex is attached to. Didn't get into the house at all. Went down the tree, lightning jumped off the tree into the ground. Didn't want to come into the house. So I know it works from my point of view. That's not to say it'll always work. But you'll see some of the things that I'll show you here on where the path of lightning goes. It'll make you understand a little bit more about lightning. 9 of the units will be for sale. We're giving one away for the 3rd prize. Okay? They're hard to build, so eventually maybe I'll put it out on the internet and let people build them themselves, but they're not easy to build because of the precision that has to be done to make sure 4 connectors come together. So let me go to the next one. This is it. The beta unit at my house is still working. It's been working for 3 years now. Opening and closing every time lightning comes in the area. So you can see I have one of the little MFJ feed-throughs. It goes to the box, and then on the right side of the box, which is the back side here, these four go to my rigs. So I started covering a little bit this. So it'd be nice if you could automatically disconnect your antennas and, grounds to make sure none of the lightning will get into your rig. And remember, lightning will find all paths to ground, not just the most convenient path. It will go through all the paths to ground. So the safest your rig can be, unplug from the antenna and unplug from the power in your closet. So nothing can get to it. How many know how a typical lightning strike is? It between 20,000 amps and 50,000 amps. That's a lot of current. That's the actual waveforms that I can't show the thing on here, but you're talking microseconds there for the pulse. So I mean, this is a 50,000 amp one. They range from 20 to 50,000. Some of them go down to like 10, small lightning. But that's the range that they're mostly in. And it can be up to 300 megavolts of power, of voltage. So this is a perfect example of showing that it not just finds the only one path, but it finds many paths to ground. So you got lightning up there, it wants to dissipate, so it's going to go hit the first thing it sees, it'll go through that, it'll go through everything at the same time. So it's not going to find the least resistance, it's going to find all the paths. Yeah, because it's looking for all, it's got to dissipate that energy somewhere. So it's going to look for all paths to ground. It'll go this path, it'll go that path. It doesn't care if this is 1 ohm and that's 1,000 ohms. It's still, some of it's going to go through that 1,000 ohm resistance. So it's going to find all paths to ground. So that's the thing that people don't realize. They say, well, if I put a lightning rod there, it's just going to go right there. No. And I'm going to show you here in a minute. It will not go just there. It's going to go elsewhere too. All right. The lightning surge protectors protect your rig. Yeah, maybe. Short answer is it depends. A lot of times lightning arresters give you a false sense of security that shouldn't be there. All a lightning protector, surge protector is, somebody sit in the front here, guys, is 2 MOVs back to back that hold the voltage between the inner conductor and the outer conductor at around 400 volts. That way you can have a 1500 watt rig, which gives you about 275 volts at 50 ohms going down your antenna. You don't want to trip it at 1500 watts. So the only thing it does is clamp those two together, but it doesn't take care of your ground path. Lightning comes in, it's going to go on the outside of the coax, it's going to go on the inside of the coax, and it's going to go through your rig. So you think about it, that lightning surge protector does nothing for your rig on the ground side. All it does is hold that center conductor to the outer conductor at 400 volts difference. That's all it is. That's all it'll do. So it won't prevent your ground currents going through your rig, so be careful there. Here's a simple diagram of what a surge protector does. Looks like 2 back-to-back Zener diodes. It's set at 400 volts. And you can see it does nothing for the ground. It goes straight through your rig. Half the current will go through your antenna ground, and half the current will try to go through your utility ground. And if you have a 50,000 amp hit, 25 kiloamps is going right to the ground. The other 25 kiloamps is going through your rig to find earth ground through your utility. That's the key. Wow. Okay. So I've got 3 scenarios here that I passed through SPICE simulation and design, just to show you the 3 paths that lightning can take. Most people are in scenario 1 where they put up an antenna. They got a ground at the bottom right where it enters their house. They got their surge protectors there. And there's no LRS in line, which is this device here. And they just got ground rods only at the antenna. The second thing is if you got a ground rod at the antenna and it's tied to the utility ground, and I'll show you how that helps, but it doesn't completely solve. The third one is when you put one of these in line. So I got 3 different scenarios. I'm going to show you where the lightning goes. All right, this is a typical scenario for every ham hit probably in this room. They got their antenna ground right there at the outside of their window. They got the utility ground coming in, but guess what? There's a ground that goes out right there. And what's going to happen is, and I'll show you in a minute, with this right now, you have a 126 megavolts. If you have a 50K amp hit, you got 126 megavolts at 25 kiloamps going through the ground. What's to go to ground? Half of it's going to go through the antenna ground rod, maybe half, it depends, but approximately half. The other half is going to go through your rig. Lightning surge protector is not going to do you any good. It's going to go right through the, and all the rigs that I've repaired that have been hit by lightning, it's the ground paths that are all burned up. Okay? We take a look at that with put it through a SPICE modeling. This is a model of a lightning hit of the scenario 1, 50,000 ohms, and I put like 2 ohms for your resistance of your line. 50 ohms is a typical ground rod resistance in today's earth here. And then the actual equivalent earth ground is out there local to you where it's trying to dissipate all the energy too. And that's typically 5 kilo ohms per meter square of the earth. So that's where you put your simulation voltage, and you can see what the current is going through your rig is basically 25 kiloamps, and can't see with that glare. And the rig voltage is 50 kilovolts. Okay, no rig in the world, ain't nothing going to save you here. And so your house voltage actually gets affected here too, because it's going to try to go through your house, through your rig, and get into your house voltage. Okay. Second scenario, the ground rods are connected to your utility ground, 4 to 6 gauge, going from your antenna ground to your utility ground, and but you still got half the current going to there, half the current going between the two grounds, and still you got some current going through your rig to find utility, because it's going to take multiple passes to find that utility ground. You look here, yeah, it helped out a little bit. You reduced your rig voltage down to 25 kilovolts, and it reduced the rig current down to 12.5 kilovolts. But you say, okay, that's still, I can't protect your rig's not going to be able to take that kind of current. So, third option here, you put one of these in thing. LRS is open. Does it detect the lightning 10 miles away? So you still got your grounds connected together, which you should. And we'll take a look at that. 0 amps tries to put a voltage potential of 50 kilovolts across your across the LRS, which is across your antenna in the rig. But 50 kilovolts is only 1 inch of open air. The arc, 1 arc. But this thing opens it up to almost 6 inches, 5.5 to 5 3/4 inches, depending on where I set the limit switches. So you're talking almost 480 kilovolts capability that this thing will isolate. That's pretty good, okay? And you can see the currents here, so it looks good. You still got the same numbers up there, except now you will have 0 going through your ground on your rig because it's open. You'll still have a voltage potential between the input and the output, but it won't be able to traverse that air, because air is basically 75 kilovolts per inch to make it arc. Okay? And I'm looking for critique here. If anybody disagrees with me.
What does the lightning do to the device?
Nothing. Because it's isolated. Because you got to remember, all the electronics are on the rig side.
Right.
There's nothing on the antenna side. And I'm going to pass this around in a minute.
Are you basing this on everything tied together common? In other words, it ain't like somebody has outside their shack, they have a rod in the ground, and at the house you got the other ground. You talking about actually taking a copper wire and running it?
Absolutely.
That's how
Most of the
mine
guys are not doing that here too. It's kind of, you need to bring that up, that they should tie everything together.
You have to.
Yeah.
You have to, because now, and everybody goes, well, you're still going to have big, what happens is lightning hits, it's going to bring both potentials of your house and the thing up at the same time. There'll be a slight difference because the inductance of that underground wire, but it's going to bring both of them up. And therefore, they're equal, pretty much. There's a slight difference because of the inductance.
They need to know that. They need to bond all that stuff together.
Yeah. Oh, and the other thing is, most people just put those little ground clamps. That'll work for the first 6 months, and then after that, it's all, it's gone. It's because of corrosion and isolation. You have to do the thermal bond. Yes, sir.
Use copper wire or copper strap.
If you use strap, it's better because you have less inductance. So what's going to happen is that if that earth ground, this one right here, that bottom one, will, depending on how long it is, we'll put an inductance which will delay the time for the bringing them up. So one will be slightly ahead of the other when you bring up the whole potential on the ground. Okay? If you have strap, it's wider, less inductance. It makes that differential a little bit less. All right, so you say, how do we do this? Well, here's an example of my setup. Lightning, you got a ground rod there, you got them tied to your service utility ground through a 4 to 6 gauge. It will handle the current. 4 to 6 gauge will handle 50,000 amps for a brief amount of time if you have good connections. You got to have good connections. You have any corrosion in that? All right, so how do we disconnect automatically? We do it with push-ons. A lot of people say, push-on connectors aren't good. I ran these things at 1500 watts. They work great. But you got to do not get the cheap Japanese push-ons because they will work a few times and they're shot. So what I've done is, let's see if it's on this sheet. Yeah, again, the safety sheet is going to be, so what, excuse me, I'm bumbling a little bit here because I've been pretty busy today. So what I do is, and this thing has a built-in, well, let me get a little bit farther down so I can explain it to you. Here we go. I've got 4 push-ons, and you can see this just shows two of them at a time because I can't show into the picture. And what happens is this thing's connected to Wi-Fi. It's monitoring the lightning data coming from blitzertug.org. And so it's getting all the coordinates of every lightning strike around the world.
What was that website?
blitzertug.org. I'll show you in a minute.
They have a friendly.
Yeah, but I go directly to the people that supply them with their, Blitzertug. It's a German name for lightning. So what happens is you get that air gap of about 6 inches, about 480 kilovolts, as I was saying. That's what it takes to cross 6 inches of air. Assuming no humidity, no particles in the air, so forth and so on. It's all in plastic. It's got a nylon thing. The PVC and all that has a higher breakdown voltage than air. It's way higher than air, so you're good there. So it will not try to travel from the left side of this to the right side, which is your rig. So this shows 2 or 4.
That's that air gap.
Yep. That's the air gap. Right? This shows it in the open position. Okay. So I put some design requirements on it to automatically open if lighting is within whatever you set the radius that you want for your particular station. And it opens it. Also have an open collector output. So if you want to disable your push to talk in case you're doing remote, you don't want to transmit into an open antenna because you're open. And it monitors lightning, and if it's within 10 miles, I set mine at 10 miles, it'll automatically open and it'll send me a text message. In a minute, we'll actually demonstrate. This is one without the cables on it. It'll send me a text message saying, lightning in the area, I've opened up your antenna rig. And it'll defaults, if lightning's in the area, it'll open. If you lose power, it'll open. If you lose Wi-Fi, not Wi-Fi, you lose processor power, it will automatically open. If you lose the internet, it will automatically open. The only thing you need to do is supply this thing with 12 volts that's on a UPS, because I need 12 volts to open. So a lot of people say, it's fail-safe. So that way I can be away from my home. Now, if I lose power, it's not going to send me a text message, but hopefully it's open because it's 12 volts opens that motor. This is what it looks like. So you can see quite a bit of things. We got a high torque motor going. It's coupled to a nylon screw, and which drives the inner box in and out. And I got an electronics box that holds a Pi 02W. That's the latest and greatest Pi, which you can't get on the internet anymore because they're sold out because of COVID. But they're slowly starting to come back. But I got an order for 30 of them, so I had 30 of them. So, and hardware future, if we can get somebody with injection molding, they can actually inject mold this instead of me 3D printing it. It'll be a lot cheaper. But man, it costs you $200,000 to $100,000 to get injection molding equipment to put this together. There's lots of improvements. Software, just mentioned all these checks. So unfortunately, right now the software is proprietary. I wrote all the software myself. Some people have offered me to take this commercial. I could sell it out to them. I don't want to get into the business. If they don't give that out, I will go and release the software to everybody in the world and let them carry it. So, but anyhow, that's in work right now. And of course, the guy who wants to to do it wants to charge $600, because if you think about for the lightning surge protectors that they have that they cost about $100 a piece. So he says, we should be able to do that, but they don't do you any good anyhow. So, and the units sold by me, when I sell them, if it breaks down, I'll repair it. I've got all the stuff to repair it. That's what the screen looks like. And now, if you could, go up and bring up the real data from this unit right here. So you can see up there, this is my rig at home. I took a snapshot of the screen that was showing me. You can see some of the lightning coming across for the distance. Oh, before you do that, let me point to a few things here. The left hand is the information. You can enter your station call, your GPS location, what you want your projection zone to be, 10 miles, 20 miles, or whatever. This one doesn't have the dwell time. This was at Rev 2.1, but I've added also a time delay in the protection zone. In other words, if lightning is still in your protection zone, it will not close it. It has to be out by whatever minutes you set, like 30 minutes before it closes up. Access code, software revision, your signal strength going to your thing here. And I have some stuff that actually gives you links to a radar page and a lightning page. And then, of course, you got the real-time data coming, the load, the strikes, how many strikes per second around the world, temperature, and some distance in miles for the last 2 hours. These are 2-hour charts. And this last one is a week's history. You can see how often it opened and closed. And then how many, once it's open, it has a reconnect countdown, which you'll see keep resetting itself as there's lightning in your area, and a disconnect counter, 73 times it disconnected. So, and then we can simulate lightning in the area and simulate lightning not in the area. So go ahead and go to the screen and refresh it. Okay. You can shut this down if you want. Just open it up at the bottom there. Sorry, guys. There it is. That's not it. It's live? Okay, it is. If you can get rid of that stuff at the bottom. There you go. This is a live screen. You can see right now I'm not getting any strikes, so it says, we may have lost the feed. If that feed goes away for more than 10 minutes, I'm opening it up. Okay? And let's see. Oh, do a refresh, because you may not, it's been sitting there. Way up there, left hand. No, not, I'm sorry. Upper left, right there. Do you see the little circle? Right above. There you go. Okay. So let's true data. So right now, you see you had 1 strike per second, and you see the lights turn green. And so this is the whole thing. So if you would, hit simulate lightning in the area, and we'll wait. Watch the red light come up. Say you're 5 miles out, because I simulate 5 miles on the radius. Takes a little bit. There it is. And when it comes up, it says, bring it up. It says subject K5Oz.development, which is I put my call up there. Message lightning within your protection zone. Antennas disconnected. Okay. Now hit lightning not in there, or simulate lightning not in the area. Send me another one, which says subject K5Oz-development. No lightning in your protection zone. Antennas connected. So, all right. Why didn't it open here? Oh, because I have it in manual. So let's try it again. So hit disconnect. No. Simulate lightning in the area. I'm sorry. My terminology. See, the thing has 3 position switch. You can automatically open it, close it, or have it in automatic. So if you want to go away and you say, I don't trust the internet. So it's opening now. It takes 2 minutes to open and 2 minutes to close. So we'll let it go all the way out and you'll see it go out. Then what I'm going to do is disconnect this and I'll pass it around so y'all can see. Any questions while it's doing that? Go to local lightning map. And it takes the coordinates and centers the local lightning map on your screen. Say accept all. There should be no lightning within, there's no lightning in the area. So zoom in, or zoom out, excuse me, so you can see. Roll it. There you go. Keep going. Keep going. We'll find some lightning somewhere in the world. There you go. There you go. There's all the lightning in the world. You see it every time it hits, you see boom, 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 boom. And it's detecting that. If you go to the other screen, it sees those, and you get some signals on there. There's not a lot of lightning happening today, which is pretty good. You can click to that other screen. There you go. You can see 1, 2 strikes per second. So
You need to disconnect the internet cable from your. A lot of guys have their monitors hooked up to their radio, or something. So if you wanted to be safe, should you keep that unplugged?
that's another. I'm talking about. You're absolutely correct. To protect lightning coming in from your utility, you have to do several things. You have to put what they call a HEPD protection device, high energy protection device at your outside, which uses MOVs to hold the voltages between the phases. You only got one phase coming in your house, but hold the voltage between the hot and neutral to whatever you buy the unit for, which will be 240 volts. They have it just set a little higher, it's probably about 300 volts. And that helps that, and of course, hopefully the rest of it will go to ground. And if you got internet coming in, that's a different story, because now you got a cable you have to worry about. And so that's another. I run everything on Wi-Fi. I do not connect directly to it land on my rigs. And I know you suffer some speed, but guys, that's the best way to do it. I'm telling you, suffer the speed, because a lot of times the lightning will not come through your antenna. It hits a couple doors down and comes over the internet or through the power, gets right into your rig that way.
Yeah.
Bingo, bingo. So anyhow, so hold on before we go. So you can see it's already opened up. And if you hit the simulate lightning not in the area, started going back in. And it's got little lights on the top. It tells you which way is it going. You know, red means it's opening, green means it's closing. And we'll let that close. You'll hear it right at the end, because I mean, it takes a lot of, and it just sent me another one saying it's closed. Takes a lot of force to put those things together. I wish I would have brought that sample. Yeah, I didn't bring it in here. You got 4 of them. So that motor is putting a lot of force to pull those things together. And it actually does a good job in pulling them together. You'll hear it bind up a little bit. You'll hear it, but it gets it together. So we're going to be quiet here in a few minutes, and you'll hear it. In fact, if you want to come up here and hear it, you'll hear it actually go together, because it stops.
So, the first month, I remember you said you got some local collector transistors in there, control up and stuff.
Yeah, it's got a PTT inhibit open collector output.
You don't have to use it. You use it for anything.
Use it for anything you want.
Okay.
If you want to disconnect your power, you can put it to a big contactor,
Yeah, okay.
but it'll take 60 volts at 200 milliamps, because it's got a transistor in there that'll.
You got a transfer.
It's a FET. It's a 2N7000.
How much loss in your studio you get? Like when anytime.
Whatever connection, yeah, it's 0.1. I measured it at 0.1.
Oh,
Yeah, because it's just a regular push connector.
right. Like with the
Here,
Yeah.
wait a minute, still going. Boop, it just
Yeah.
hit the limit switch.
Keep the thing from misaligning as it joins up.
It's just precision, because it's square and square. It can't turn on either side, so it's got to come together.
Go through a tube or something, or keep it aligned.
I'm going to pass this around. You take a look.
Inside the box.
Inside the box.
Ready to go back to your present?
Yeah, first of all, disconnect, shut down Raspberry Pi, because I don't want to, no, down at the bottom, red. There we go. So,
Using no grade?
yeah, using Node Red.
Okay.
Be careful, guys. Even though this is pretty sturdy, if you drop it, it's going to crack because it's plastic, okay? So you can see how it's pretty much built. Okay, we're doing good. It's 4. Total of 4. So any questions about the theory behind that, guys? And I know there's a lot of people. The biggest problem that people say, well, I had all my stuff connected together. The key things is when you tie your grounds together, you got to thermally weld them together. If you don't do that, you better be out there checking it and putting a new one on every couple of months. CAD welding, that's the absolute thing. And once you do that, you got it. Because that melts it all together. Uh-oh. So,
Anybody ever tried silver soldering? I know the code doesn't like
it's the reason why silver carbon, because as soon as it starts heating up, it pops open. Melts.
even with silver soldering.
Just, yeah, it's a little bit higher than regular solder, but it's better than nothing.
But
But
better resistance, you've got to have some resistance to make it hot. So, the other stuff, still a little bit better, but it helps stand.
yeah, you got to realize that lightning will, even in a 4-gauge wire, you pass 50,000 amps to it, it's going to get hot very quickly, and it's going to expand.
Look at a fire truck when it gets hit by what happens. You see the bar fall, it's going to sap from the moisture and get hot. It blows it.
Right.
Yeah, careful, it's been Dave on a long time.
See the way it blows the tree apart.
Yeah, it does blow the tree apart. Yes, sir. Hold on, we got a question here.
So this is something that you're really going to have, telling your rig, I'm open.
Yeah, what my rig has is a TTL input. It has 5 volts on it all the time, and of course that when you put that to that open collector output, it pulls it down whenever it opens up the thing, so it tells the rig that the antenna is open.
So this will inhibit your radio.
Yes.
See, I had that question. What if you're operating remotely and you run a kilowatt? Like, and you want this thing opening up while you're transmitting CW?
Well, that's what I'm saying. It sends the push to talk, which inhibits. You got to have it an inhibit line for both the transmitter and the amplifier, and usually they're tied together.
Yeah, that's right.
So with the open collector output, you can tie that to another relay. So right now it's easy with a flex because it's just looking for a TTL input because it pulls that high. It's completely open collector. I don't have a pull up or pull down on the open collector. So you supply it with a relay that has 12 volts. It'll pull that relay down and get your contacts, whether it's open, normally open, normally. Yep. You can break your PTT line. You can do anything you want with it. Any other questions on that? Is it passing around? And what I'll do.
It's a Wi-Fi, it opens up on that, right?
Yes, yes. Yeah, you got to make sure it opens up, when you lose connection.
I mean, a lot of times
But it doesn't do it immediately. It waits for about 10 minutes.
okay, that's fine.
Because I don't want it.
Power goes off, you lose your Wi-Fi.
Right. It opens up.
And Rico drops. Starters right behind.
Oh, yeah, that's exactly. That's right. That's right.
So anyhow, let me back up a few charts here. And I get most of the people asking about the simulation models. If you have any questions about that. Now, this assumes that all your grounds are good. They're tied together, and they're of sufficient, gauge to take your current for those milliseconds that, lightning hits. Because, and that's where a lot of things people go wrong. Now, you see that thing I'm passing around? Most people will say, well, just set it next to your rig. Guess what? You may have less than 6 inches between that thing, the hot side, and your rig. Or the cable's coming in, it's in a ground. You got to keep all that ice because it's going to try to find the path of least resistance. Well, it'll find all paths. Excuse me. It doesn't just do the least resistance.
If it's out the end.
Yeah.
So Dave, I know how you are. Did you ever teach developers?
Yes, I do. To make them easier, I put on the inside of that box. it has a bunch of harnesses out to the limit switch and the power input and the USB input. And the new board that I'm building, which will fit in that same box, has it all on one board. So you mount the limit switches and everything's on the board, so it just goes right in. I don't have to make the cables. Making those cables is takes a long time. That's where a lot of the work comes. And I wish I could pull that box. If I had a metric Allen wrench, I'd pull the box off and show you. But the person who's thinking about buying asked me not to show any guts and schematics and stuff yet. But like I say, if I don't commercially, I'm not looking to make money on this. I'm looking to, supply something people can have and help their rigs from getting killed. So
You can help a lot of public safety too with that thing. I was thinking in my mind, some of the stuff you can do with that and them. They have backups where you could actually disconnect the repeater main feed line plus send a signal so you've been disconnected, and then with the open collector relay.
you can disconnect the PTE.
That's right. It could be on a backup unit and smaller where they're not just like the polyphases, all they've done over the years for us, they make the insurance company say nothing's burnt. It's all broke, but nothing works, nothing's burnt. So what we do is take a benzomatic torch and burn a hole in the damn circuit board, and then they're happy. Oh, look, we got it struck all right, and we'll pay for it. Because the polyphase is just like being in a gladiator pit. You go in there with no shield and armor and you get hurt. But if you have a shield, you can keep Leif Erikson from putting his axe through you. So you still get killed, but they don't show you.
Yeah.
But anyway, go through the same bullshit with the damn polyphases and all that. The other thing too, like Dave said, all your grounds got that entrance ground that comes in from the utility pole needs to be tied to your rig ground. That's important. You can't have two dissimilar grounds. You're going to have all kinds of problems. The other problem we had years ago, we had stuff on water tanks, communications on water tanks with antennas. We used to use what they call a dry line pair that went to the phone company, key a relay to keep it transmitted. What happened over the time, the water tanks, they said, the water tanks are hard, they got shot. It never came to the water tank. It came to the damn phone line. The metal pair come across, jump across, and burn everything else, but it was because you go to that height, but anyway.
Marvell says, we don't take like you did. Man, you're bonded on a damn utility pole. I'm telling you, you don't take like that.
Oh, we're going the wrong way here. Oh, this is backup history. Let's see if I got any. I got some pictures. There. I didn't realize I had some pictures. That's a picture of the inner box. And you can see where the push-on connectors attach. And there's a picture of the outer box. And one made here. And of course, I'm using something different now. Those things take 28 hours to print. So I went to Home Depot and bought some fence posts. Redesigned the inner box so it would match perfectly inside of that. And then I chopped those up. And then I have to machine the holes. These are little viewports so you can adjust your limit switch that make sure it's all the way in. And so it works out like a champ.
Spent more time mechanical than you did writing the code for it.
The code took a little bit. And of course, that's what the inside of the box looks like, of the electronics box. This little thing on the top, you can see the two limit switches. They're not in place. I just had a model to verify that they would fit. And you can see there's mine. Oh, by the way, I have 13 out there that are in beta testing, and 13 people have them. And they've been using them for the past year. And I've had one problem with one motor that was, I guess it was infant mortality. It just burned out. So I replaced that, and the rest of them are good. And let's see, here's some pictures of it. You can see the little board that I designed that the Raspberry Pi sits on top. And there's the coupling for the motor to the nylon threads. And there's you some pictures of the inner. That's that's the old Beta 1. And of course, there's another picture of it here. And that's without the outer box on. Anybody guess what that little hole up there that doesn't have anything in it is? Magnet for the limit switch. If you noticed on top, you had, if I put my limit switch on that side, guess what? It's less than an inch away from the hot spot. So the limit switch has to be on the safe side, which is the right side. So it's attached through PVC or printed material to get to that, and that the magnet pulls that out, and of course it pushes it back in when it goes back in. And you can see that's what that is up there in the upper right. You see it actually stopped because it pulled it out and got it from underneath the limit switch. That's what that's my personal board in there that handles the motor reversing and all that. Current limited, by the way, it does have a PTC, which is a automatically resettable fuse. And that's it. So
I ground all my rigs together. Basically, pull the plug, and just take the antennas, but I do need to improve the ground outside, like you said, I don't have it welded. But if you don't go in and put ground wires to every radio, and I know I got my ground to the house and to the ground rod on the antenna. Is that still good enough? Well, I can take the computer stuff loose if I had to.
yeah, what you need to do, if you really want to be safe and you don't have all your grounds isolated, you need to disconnect your rig from the antenna and disconnect anything going to your rig from internet or whatever you have, unless you have a Wi-Fi thing. And of course, a lot of people say, well, put Wi-Fi on there. Well, guess what? It's still going to come through your power supply to get to that Wi-Fi, so you got to watch that. You have to disconnect the power. So which gets back to what Pete was saying, with that output, if you wanted to completely disconnect your rig, you could put a big contactor there and disconnect everything on the power. Now you got to be careful, because a lot of times NEC and the house codes require you can't disconnect ground. You can do anything up there. But you got to watch that, but if in this particular case you would be good, because you put a box specially and you disconnect everything, your hot, your neutral, and the ground from the rig, and so you completely isolate your rig. That's the best place for a rig during a lightning storm, is in your closet, unplugged and disconnected from the antenna. Now, if you have any wire that's stuck into the antenna, it could get magnetically induced to it and get your surge. But typically it won't get into the rig itself. And then we're talking EMP. If you ever have EMP, it doesn't matter, the rig itself.
Well, be going anyway. Hope you got ground zero when it goes off.
Yeah.
Right.
My neighbor had a little EMP from a lightning strike. It hit behind his house, but I don't even think it hit his house. The fiber box on the side of the house got blown off. And his truck sitting in the front driveway, the computer got messed up. And it wasn't even, it was behind his house.
Inductive pickup is what happened.
That was
Yeah, like 2 years ago, I had a real bad lightning. It hit my neighbor in the back. And I was physically watching and could hear it sizzle the ground. Took out our modem, took out lots of stuff in the house.
Mhm.
It didn't even hit us.
Yep.
In your body unit, you get documentation that shows where everything's at.
Yes. It does give you documentation. I wanted to get back to that. That right there tells you everything, guys.
Yeah, that's my fault.
But yes, well, that rod's fiberglass. Why did it go through the rod? Well, what's happening when lightning goes, it doesn't matter even if a leader starts going up to the sky. What's happening, because it was probably raining, that rod was wet. So once the leader got up there, and then the streamer came down, when they meet, that's when the lightning goes down. And then the lightning actually traveled, it ionized the air, so the air was the conductor there. It hit the ground and it says, I still got to dissipate all this energy. So it didn't go just in one direction, it went every direction to try to dissipate it. And you can see what... So anyhow, lightning can do some damage. I can't guarantee this thing will keep lightning out of your house, but if you do all that stuff right, it will stop most of
Well,
it.
you design to protect the equipment.
Right.
But you worry about refrigerators and dryers.
Right.
and everything.
Well, that's where you have to go to the other part. Put your stuff at the input.
There's 6-inch space to put a foot on it.
Yeah.
Well, you gotta make sure you got it burnt, if insurance comes.
Yeah, right.
This is natural wear and tear, so get a propane torch and burn it.
Glenn will find you there. That's only intangible Paris.
Right.
Any other questions, guys? We're getting pretty close to, yes, sir. Right now it is posted, and you can go, let me see if I can run this machine over here.
Last year, you posted on,
Why is this not working? Glenn, I don't know what happened to your mouse. Oh, you got to click it once? Okay. Now I got to find it.
wake it up.
There it is. I got to find it. Where is, I can't see it. I'm looking for the
Where the
mouse.
mouse is, you're all over the space.
I can see it up there, but I can't see. Where is your internet? Here we go.
Dave, you selling it?
Yes.
What's the price for it?
$2.99.
Yeah, right. Yeah. Yeah.
All right. Listen to the guy. This will tell you how to get to there. W5Sla.net. And then once you get there, you go to About Us. Go down to Photos and Files. Come on. Yeah, but it's not clicking it though. There we go. Then come over to Members. And then you look for me, David Hartley. There we go. And then you look for Lightning Rig Saver. And then you can go, here's how you set it up. Here's that presentation I just showed you. And here's these instructions. Here's how you do the initial setup. It actually goes into a lot of detail here of how to set it up and how to set up your rig and where the outputs are and so forth and so on. And I'm sorry? Oh, just email me. Yeah. And let's see, and of course, let's see, there's your, the latest software is at 3.3, and I've already taken it off there. And I update that periodically as if any problems come up. Hey, I'd like you to do this if you can, and I'll look at it and see if that affects a lot of people. And then, like I say, that's the thing. You can take a look at it. It has this presentation, and you can study it in detail. Yes, sir. Oh yeah, I got a table outside. I've already sold 3, so I've got 7 more, including this one. So anyhow, come out there, guys. I'll actually take that and let it come open out there for you.